All right. We're going to start now with the talk that I think by far has the most interesting title of the event. Catch Dancing Ponies. Try approval testing. It's really just the first part I thought was interesting. But
yeah, the rest of it's no good at all.
Over to Emily.
Great. Thank you so much. I was very pleased to be invited to speak at this event. I was here 2 years ago, actually, and I spoke then about software craftsmanship. And I was very pleased when Jeff invited me this year. When I spoke 2 years ago, Bache Consulting was my main business. And now, since then, I've been working for Pagero as my main job. And I do a bit of consulting still on the side. But really, my main work now is at Pagero. So I'm going to talk a little bit about my experiences there. So we have this product, Pagero Online. And if you surf to this URL, you can see the login page at least. I can't, let you all log in and see what it's about. But the point is we have this, this product. It's a cloud-based solution for electronic exchange of documents between businesses. I'll come to that. But the point is we have an extensive suite of automated tests for our online web application. And it wasn't me who wrote them, actually, but they are very good, very well-written tests, fully buzzword compliant. They're written in Groovy with Jeb and Selenium, and they are really cool. But I have to tell you that one thing that worries me occasionally is that this test suite, I'm convinced that we have no test that would catch this particular problem. That if maybe one of our developers was feeling a little bit, they're jokey, and they were working late one night and decided to put dancing ponies on the front of our web page. Unfortunately, we have absolutely no assertions in our entire test suite that say assert no dancing ponies. Not even if they put a really cute little foal that wiggles its nose. Even then, we wouldn't get any test failures. Now, of course, none of your developers would do anything like that, and probably none of ours would either, but this is actually based on a true story. This has happened, that somebody's put some dancing ponies on the admin page just for the people who are logged in as admins. Oops, it just went out to the live site and all the customers can see it. Oh dear. And I think this underlines one of the limitations of an assertion-based test suite. So I'll talk more about that, but I wanted to give you some background. So we are hoping to work in a more continuous delivery kind of way at Pagero. We already consider ourselves reasonably agile, and we have a reasonably large amount of automated testing going on, which is my real interest. So the thing with a continuous delivery is that there's this concept of the pipeline, and this is the kind of lean concept of trying to optimize from the developer developing some new features in their local environment. And then they push their changes up to a central place where we run the unit tests, and then if they pass, then we pass it to the next stage of the pipeline and we run some more tests. And as we go along the pipeline, these checks get more stringent. And ultimately we decide this is good enough, we'll ship it and show it to the customer. So the point of this pipeline is it's about shortening the lead time from building the thing to getting paid for it, basically. So as you go through this pipeline, you've got to check it and move it to a more production-like environment so that you're more likely to find the same errors as you're going to get in production. And often that means that the tests get more expensive. They get slower. There's more code in the tests, and they take a lot more work to get them stable and useful and giving good feedback. So this is typically what happens, that people find it reasonably easy to write unit tests. That's fairly well understood. But as we move through the pipeline, the tests get harder to write, harder to maintain. So I've been recently concentrating a lot more on the acceptance test part of this pipeline, because I think this is a stage beyond your unit tests, which I'm also very interested in, but actually, I think we're quite good at those most of the time. So I've been looking at the acceptance tests and trying to work out, well, what should we be doing there that would give the best return on investment? So let me talk you through what I see as being an acceptance test. Now, this is a test that's checking something that the user can see, something they care about, like that they can complete a whole workflow with your application, or that they can identify a business rule that the system is correctly checking. So that's part of it. The other half of an acceptance test is that it should be through some kind of external interface to your system. So systems have all sorts of different interfaces. And I showed you that we have a web application, and we also have a REST API under the web application, which is quite convenient for testing. And then we also, you might have a command line application or some kind of rich client GUI, and all of these are, this is what the user sees and uses, basically. So you want the acceptance tests to test from the user perspective and use the application in a realistic way through an interface that they would recognize. This is different from a unit test, which is just testing a very small internal interface from the programmer's perspective. So that's how I would define the difference between the two. So let me talk about approval testing. This was in the title of the talk. And approval testing is a technique you could use at either unit testing or acceptance testing level. It's not actually specific, but I found it particularly useful at the acceptance test level. So let me tell you more about the system that I'm testing. We've got this cloud-based service, Biggo Online, and the basic use case for this is that we have our customers want to send an invoice. They issue the invoice through their accounting software, and it produces generally some kind of XML file, hopefully, that we send up to our system, and then we send it on to the recipient, another company who's going to pay the invoice. And they have a different accounting software and wants the file to come in the format that their system can cope with. So we're like a universal integration solution for sending, I say invoices, but these days we do all sorts of other documents as well. But this is still our main business. So this is what we're trying to test. And as I said, we've got this REST API. So when I'm testing, I pare this down to, I've got our system with a REST API, and I've got two documents which I'm trying to check are correct. So I've got a little test fixture that's just a little command line program that takes a file off the file system, throws it up to the system under test, gets back a suitable response and looks at it. It's a PDF quite often. So I've got a little utility that will convert that to a text file. And I find this very convenient because text files are much easier to version control and search and generally deal with regular expressions and that kind of thing. So it's effectively just the same as the PDF, only just the text, which is actually, when it's an invoice, that's usually enough. The images and stuff are nice, but it's enough with the text. So what this test case consists of then is the input data and this output file, which the way this works with approval testing is you throw in the input data, you look at the output file, and then you decide whether you can approve it. Is this correct? And for that approval step, you might need to talk to somebody who actually knows about invoices, somebody in our business who would be able to verify that that was the right thing. But once you've established that it is correct, then you just save it, and then any future test run is just going to compare, do a diff of the text files against the approved text file. So the test case, when you take away all the graphics, it's input data, some kind of code that does a use case, some kind of output data that you can view as text. And that's the parts of an approval test case in my world. And it helps really, I guess, that for our system, there is really this one use case of sending a document that is the use case. And so all our tests are basically just variations of inputs and output data, really. So this means there's very little code for a new test. It's just new data. But anyway, with an approval test then, what happens occasionally, of course, is that you get back some output that differs from the approved output. Did anyone spot some dancing ponies in this invoice? Oh no, we've got dancing ponies. And actually, the thing with this test is it's going to fail. Yes, the diff tool is going to, with no difficulty, recognize that there is an extra line on this invoice. Suddenly we're giving away free dancing ponies. Great. The thing is, at this point, we don't quite know whether this is what we were intending or not. Is this a bug or is this a feature? Well, okay, it could be either. Let's imagine that this is a defect. We didn't actually intend to send out dancing ponies to everyone. And great, we do have a test failure. The thing is, just think about that. If we only had assertion-based testing, would you have remembered that assertion? Maybe you'd have had an assertion that would have picked out the number of rows in the invoice were only one. But still, this is the point with the approval test is that by default it's picking up any change as a potential problem, which means it can catch errors that you never anticipated when you design the test case. With an assertion-based test, you look at the output and you pick out a few things to assert on what's on the screen, the things that you think when you're designing the test will probably be important. And if you forget something important, the test will never tell you. So this is a major strength of approval testing. Okay, let's look at the other scenario, that maybe this actually wasn't a bug. Maybe we actually intended this. Okay, maybe it's not very often that we decide that everyone should have free ponies. Unfortunately. But actually, one of the things we do with Bigera Online is we do add data to people's invoices, which they actually ask us to. We can add extra fields that their accounting package maybe doesn't support for some reason. So it can happen that the output does change, and maybe in this case this is absolutely correct, and we wish to approve the new output effectively. So we need to basically replace the approved output in the test case. And it's at this point where the tool support really starts to become important. Because if you're using a unit testing tool, which doesn't have explicit support for approval testing, you're kind of thinking, okay, well, I'll get an error message with a diff, and I can copy the text from the error message and paste it into the test file, and then it will pass. And you're thinking, there's quite a potential for human error there with the copying and pasting step. So here I think you really need a tool to help you. There should be no potential for getting this wrong. And I use a tool called Text Test, which is built for exactly this kind of thing and makes it really easy to update your approved output. So Text Test is an open source tool for approval testing, and it does other kinds of testing too, which I'm not going to talk about today. It's got a website. There are other tools available for approval testing, and I should give a mention for Llewellyn and Falco's tools, approval tests, which I have only dabbled with, really, but I've heard good things about them. So anyway, we're going back to this scenario where we have a change in behavior and the test fails. Now, as I've pointed out, the thing with the approval test is that it can find these changes that you didn't anticipate. And that's great, so long as those are bugs. But I can tell, some of you may have thought a bit further and thought, if I did this, my tests would fail absolutely every time. Because actually, one of the things I've got in my invoice is like the date. And the date changes every day. I don't want my tests to fail every day. No, okay, we thought of this. This happens to us. The date on the invoice does change every test run, and we don't actually want the test to fail because of that. So, right, brace yourselves. I'm going to put some code on the screen. This is a regular expression. It's a form of code, and we use these in order to filter the output before we do the comparison, so that we can make sure that the the varying strings get replaced by fixed strings, that will not fail the test every time. So the thing with approval testing, it's always a balance between, by default, you check all the output, but and then you pick out the parts that you wish to ignore. Whereas with an assertion-based test, it's the opposite. You start by not checking any of the output, and you have to pick out the small pieces that you do care about. And it's the different philosophy. And this, I wanted to try and compare these philosophies and why I think that the approval testing works so well, particularly for acceptance tests. So if we look at unit tests and acceptance tests, I talked about this a bit already, that we have a unit test is just for a really small piece of functionality, and the idea is that you can then pinpoint where the problem is. And what is desirable with a unit test is that every test should be isolated from every other, that not only do the failures not cascade, that one failure causes others, but you get one failure per defect. That's the desirable case, so you know how much is broken. And if you have a test suite of 100 tests and you get one failure, oh, I've got a failure. And if you get 80 failures, you're like, oh my God, this is going to take me weeks. We haven't run these tests for so long, we have 80 failures. Whereas for things can be quite different with acceptance tests, because there we are testing a whole feature, and one failure is not necessarily one defect. It could actually be more than that, because you're testing such a large piece of code. The failure in one part of that could be hiding potential failures in the rest. And it is, as I've been trying to point out, sometimes difficult to predict all the things that the user is going to care about. You have to anticipate all the things that you're going to need to assert. So it's a different situation. There are other differences as well, but I think we've learned a lot about unit testing over the years, and it's useful to be able to think about how we do unit testing and why it's okay to be different for acceptance tests. So unit tests have got this concept of arrange, act, assert. Even if you're not a coder, hopefully you've heard that you set up some stuff, you exercise it, and then you check the results. And that maps fine to the test cases that we've been talking about with the input data, the test code, and the output diff. So you can map this. But then when you're looking at the assertion, in a unit test, you generally write one or two assertions. The approval test is asserting every single line of the output. So it's like you have a unit test with a huge number of assertions suddenly. And that means that in a unit test world, that would be bad unit test design. That would be cause problems with isolation. What you want in a unit test is isolated test cases, one assertion per test case. Whereas in the world of approval tests, you don't get that. You get this phenomenon of related failures. You get a whole load of tests failing when there's actually only one problem, because most of the tests are sharing assertions. I'll give you an example. That's a bit theoretical. But the idea is that, okay, you've got two test cases, two different invoices. They're slightly different items, and both these test cases are passing, everything's fine. And then what happens is you make an unrelated change. For example, internationalization. You decide that these two addresses need to have the country on them. So both of these tests suddenly get a change. There's a new line in the output. Both the tests fail. And suddenly you get a test suite where you have a lot of related failures. It's the same underlying issue, but you get many failures. And this is why the unit tests are trying to avoid this by just having one assertion per test. So this means that you need a different level of tool support to help you realize that this isn't, in fact, two different problems. This is two aspects of the same problem. So I'll just show you how text test would help you with this. So this is a screenshot. On the left, you've got 4 test cases that I've run, and you can see that there's one line per test case. The bottom one is green. That one has passed. The other 3 have all failed. And on the right-hand side, you can see this kind of status window where it's saying, yes, we've got 4 test cases, 3 of them have passed, but it's grouped together 2 of the failures. And what it's saying is that those 2 failures were related. They were exactly the same issue, which means that I can deal with them as a unit. I can see I have 2 problems here. I have group 1 problem and this other test case that's done something else. So this means that I can treat this as the grouped failures all at once with the same regular expression fix or the same approval. And this means that because of the tool support, related failures become not such a big problem. But then there's test-driven development. Now, this is something that is close to my heart. I think we should be doing test-driven development. And when you're doing the way that I've been teaching TDD for many years now is all about unit tests. Although, because it's much easier to learn TDD with unit tests than it is with acceptance tests. Although, of course, you can apply all the same benefits if you get the acceptance tests into the loop. And these people here have all written about how to do acceptance test-driven development, and I admire very much their suggestions. But the thing is, of course, with an approval test, it's not quite the same as writing a unit test, because here I've mapped all the parts of my test to a so here I can see that if I haven't built the feature yet, if I'm trying to write the test up front, these things are very hard to get hold of because I haven't got the system to run to get them. So I can't actually design the whole test case up front like I might be able to with a unit test. So what happens is, though, that I can find the input data, I can start designing my test case, and I can start implementing the feature and using the input data, and I can look at the output, and it might not be completely correct yet, but I can start approving it, and then I can do some refactoring and check that I didn't go backwards at least, and then I can implement some more of the feature and see the output improve, and at some point I've finished with the feature, and I can make the final approval, and the feature is done. Now that doesn't sound exactly like acceptance test-driven development, maybe, but actually I think even if you're using another tool, you don't actually completely define the test before development starts. It's always a process during the development to develop the new feature and the test together. So I don't think this is such a radical departure as it might first appear. So acceptance test-driven development, this is great. This is building tests for all the new features that we develop. But actually, in practice, we've been developing this Big Arrow Online system for a number of years, and over the years, we've developed a legacy, code that doesn't have quite the tests that we would like it to have, and that we are not completely confident to go in and change, because we don't know quite what will break. So actually, the situation we're in right now is that we're doing a big refactoring. We've got a monolith and we want a microservices architecture. So in pictures, we have one great big application. It's a J2EE monster. All our code is in this one kind of process space. And we want to have a microservices architecture because this would be so cool, because all the cool kids have these days. And Dan North talks about these, so they must be good. But there is a good business reason for this too. The point with the microservices architecture is if you need to increase the scale, the number of invoices that we're handling is doing this at the moment. Business is going well. We need to scale, and with this architecture, we can just add machines and more services, instances, and then we'll be able to handle the load. So there is a good business reason for this as well, not just that it's really cool to work with. Did I mention we're using Scala and Docker and all this? Yeah, it's cool. So anyway, so what I've been finding then is that in order to support this really big chopping up of our architecture, we need some really good regression tests to find out if we broke something. And I've been just recently doing a lot of characterization tests, which is very similar to a regression test. Let me explain it. We take some input data that we've found in our production database. We've got millions of these invoices in our production databases, so I find some appropriate ones. And I can then send them through the current development version of our application and see what comes out and compare it with what I found in the production database for when we ran this before. And I can then compare it against this characterization of what actually happened before. So the reason I'm not calling this a regression test is because in a regression test, you know that the behavior has got worse. You say it's a regression, it's got worse. Whereas in this case, all we can say actually, well, it's different. The system, what it did before, we're just going to say that's a characterization of what it did before. It may not actually be correct. The result that we get today might actually be better. It might not be a regression. So we're just going to call it characterization test because it's just a difference. And any difference is treated as a failure until you can work out, no, actually, this is an improvement. So this means that approval testing is absolutely perfect for this case. This is exactly what approval tests do. It's all about comparing with another approved version, except in the case of these characterization tests, it's not actually approved, it's just what it did before. So we've found that this has been really valuable for us. We send in the same invoices before, we check that we're sending it to the same recipient, useful that we send it to the right person, and that the presentation looks the same. And this has really found issues for us. So I went into Pagero with all these great plans of, oh, we're going to do acceptance test-driven development. There's going to be all these tests for new features. And we've done that to some extent, and it's been useful. But I think the most significant thing I've done is this, really. This has found more important stuff. Writing good tests for the stuff that was already there. So it was on one of Woody's slides, I think. Don't use other people's experience as a template for what you should do yourself. Try and use it as some kind of inspiration. This worked for me. My final slide, I just wanted to wrap this up by reminding you of what I've said. So I've been talking in the context of trying to move to continuous delivery, where you want something beyond just unit tests. And the next step is probably some kind of acceptance tests, which is what we're trying to do for our Pagero Online system with this basic use case of flow of electronic documents. I've been using text test for these acceptance tests and these characterization tests, and the main thing here is that you can catch changes that you never anticipated when you designed the test. These ponies. The main difference that you need to learn to handle is the concept of related failures, that you suddenly find lots of tests changing together, and you have to handle that. And some knowledge of regular expressions really helps. But it does mean that you can find these ponies. So that's the end of my talk. Thank you very much.
So this is very useful, and it's not a revolution, but it's very useful. We did this, I think, a long time ago when I was working at a visualization company, where I actually compared bitmaps before and after to catch these kind of small errors. I think that a few years from now, we will be using machine learning techniques for this, to actually automate what should be, and have machines find those ponies by themselves by just feeding them inputs and expected outputs and find out for themselves what the patterns are.
All right. That's...
I don't think that was a question, right?
Oh, sorry. Do you think so too?
There is a certain amount that there's no machine learning here. It's just a plain diff tool that's just saying there's a difference. And it needs a human then to go and say, approve it or filter it effectively. And what you're saying is that we'll have some AI that will do that. And to some extent, they can learn from watching the human do the approve or filter, I guess. Then you could train it to do the right thing most of the time. But that could save me a lot of work if the AI was good enough. Yeah, I have reservations about whether it can learn to approve output as well as a human could. But it would be another tool. You'd have to make sure that it wasn't letting ponies through from time to time. But yeah, that's a really cool idea.
Hi. My question was about it seems like your tool is mostly a transformation tool, but I was thinking about the characterization test. When you run old input through the system, does the system... whoa, is this working? Or is that feedback from the speaker? Maybe this is better. That's all better. Yeah, I'm sorry. Yeah, I didn't realize I was standing by the speaker. Well, anyway, does your system add any state? And how do you manage persisted state? Like, for example, if there is a database with, say, customer invoice addresses. And so with input from different points in time, how do you deal with that type of complexity?
Okay, so we already have in our system support for resending an invoice through the system. So it was actually very easy to resend it at a later date. That was already built. The customers needed that. I think you're trying to ask a more general question about characterization tests, and you are right. It's not always so easy to take old input and just run it through again. Sometimes it needs to be massaged and have the dates in it changed, and it needs. That can be a big project in itself. I guess I was quite lucky with the system that it really already supported it.
Thank you.
Anyone else? Oh, Magnus, sorry, yeah, you're up.
Hello. I have also been a fan of this group of tools for quite a long time, and in most places where people say, "Oh, we can't do automated testing," or "It's really hard," or it's a very good fit and a very good place to start for most organization with something legacy or something. It's a very effective way of getting up and running and getting good coverage.
Yeah,
fast.
so that you can do really cool refactorings and start splitting up your system.
If you haven't looked into this and you're techie, you should really. It's great.
I think that it's. I'm very glad to hear that you've had good experiences with this approach too. And I think I forgot to say in my talk, I think just having this word for it, calling it approval testing, makes it easier to talk about and share experiences. Because I think there's probably a lot of people who are nodding and thinking, oh yeah, I kind of did that. But having a name for it means that we can start to discuss the pros and cons and start to put it up on people's agenda, that there's more to automated testing than making assertions and hand-coding assertions.
And it also helps drive the development of the tooling to do it, because otherwise it would just be special case stuff that you would do for yourself, and now it's kind of a place to put these things.
Yes, a lot of people roll their own and start building their own tools because they don't know that there are tools out there, because you can't Google a tool for an approach you don't have a name for. So that's one of the things I'm trying to do, is say it has a name. There are tools out there. Text test isn't the only one, and it can almost certainly be improved upon.
If you can't Google it, it doesn't exist.
No, quite. Yeah. So
Are we done, or do we have any
done.
time left? Anybody have any more questions?
No?
All right.
Great.
Thank you very much, Emily.
Thank you.